Good day, and welcome to the Plant Engineering webcast, Managing Industrial Odors. Learn how to pass the smell test. Sponsored by EcoSorb. I'm Kevin Parker, an editor with CFE Media, and I'm happy to join you today on behalf of Plant Engineering. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh the browser or click the Refresh Media button under the presenter's picture. Control the volume of this webcast by adjusting the volume on your computer or on the webcast platform. For technical problems with the audio or slide presentation, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. The Ask a Question box is also used to ask our speakers questions. The live Q&A session will begin after the presentations conclude. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and other additional resources, use the Event Resources tab on the left-hand side of the screen. These documents will also be available with the on-demand version of the webcast. I'm now happy to introduce today's presenters, Dr. Laura Halpert, Brian McLaughlin, and Jennifer Klennert. Dr. Laura Halpert joined OMI Industries in May 2012 and serves as the Director of Research and Development, responsible for product quality control and assurance, laboratory testing, formulation development, and other related areas. Dr. Halpert manages the R&D Center at OMI's Operation Campus in Rising Sun, Indiana. Dr. Halpert earned her Bachelor of Science in Chemistry with a biochemistry concentration from Manchester College and began her PhD studies in physical chemistry at Purdue University shortly thereafter, working in solvated clusters. Dr. Halpert also completed her postdoctoral research at Purdue. Jennifer Klennert is a Senior Client Manager with Foth Infrastructure and Environment, LLC. Jennifer has 28 years of experience in negotiations, program planning, and relationship building in the environmental industry. Jennifer has a Bachelor of Science in Environmental Science from the University of Minnesota, a Master's of Science from Metropolitan State University, and is currently studying for her MBA at Carlson School of Management. Jennifer is actively involved with the Solid Waste Association of North America, Minnesota chapter as a past president, secretary, and board member. Her background includes authoring technical and research documents, operations, problem resolution, and a focus on partnerships. Finally, Brian McLaughlin is the Director of Sales and Marketing for EcoSorb, the industrial division of OMI Industries. McLaughlin has held many management positions in various areas within the OMI ranks since 1993, crossing all EcoSorb products and equipment, including product design, manufacturing, sales, and marketing. Brian studied finance at California State University at Long Beach and holds numerous certifications in sales, marketing, and manufacturing techniques. He is also involved with many professional associations and organizations through OMI's membership with the Water Environment Federation, the Solid Waste Association of North America, the National Asphalt Pavement Association, and others. Brian resides in Houston, and Brian, the floor is yours.
Thank you, Kevin. First of all, I want to welcome everyone to this presentation. We appreciate you taking your time today to join us. We're going to try to share with you the chemistry, technology, and expertise we have in odor control, and more specifically in the plant-based odor control technology. We'll talk about a little bit about OMI Industries. We'll talk about why odor control is important. One very specific area of the difference between odor control and emission control. We're going to talk about applications in the different markets. We're going to talk about EcoSorb, which is the natural solution to odor control. We're going to talk about reliable odor measurement technologies. We'll give you some case studies and then take some questions. So first, a little bit about my industries are chemistry, technology, and expertise. We started this business in 1989, so we've been doing it for roughly 31 years. We are without question the worldwide leader in plant-based odor control technology. We've got manufacturing in Rising Sun, Indiana. Our R&D center is also in Rising Sun, Indiana, that's very close to Cincinnati. Our headquarters are in Chicago. Our expertise does lie in all markets. We originated with the industrial group and then expanded that into the consumer marketplace in 2003. We now have products for the house in all the most major retailers around the United States. We also started a commercial division in 2009 where we deal with hotels, hospitals, and the rental car industry. So let's get into industrial odor control and why it's important. First of all, it starts with the community surrounding your facility. Back 20 years ago, you called an agency, they filed a complaint, maybe you went to a town hall meeting, maybe you went to two, and everybody hoped it went away. Today, it's not the case. It's a lot more than word of mouth now when we're dealing with odor complaints from the neighborhoods surrounding our facilities. We've had a tremendous amount of urban sprawl. As you can see in the picture on the screen, those developments were built long after that wastewater plant that sits right in the center. And now we have our phones, smartphones. There's a social media effect of odor control complaints. So it just gets larger and larger. You can't ignore it. It only makes it worse. And when it comes to nuisance violations, odor, noise, and dust are the top three, and odor is number one. So why is odor so difficult? There are currently no sensors known to mankind that can measure and quantify specifically odor without the help of the human nose. It's very noticeable. It gets in people's backyards, and it's also very difficult to mitigate. And how do you prove that it's gone, or how do they prove that it's there? It's a continuous process that the technology is growing in, and OMI definitely leads in that technology area and trying to develop the best methods to develop what an odor is, what that odor level is, and what's acceptable. At this point, we want to talk about emissions control versus odor control, and I'm going to turn that over to Dr. Laura Hopper.
Thank you, Brian. As Brian mentioned, we would like to now talk about emissions and odor control, but in order to talk about emissions and odor control, we first have to have a fundamental understanding of what I mean when I'm talking about emissions and odor. So let's start with emissions. So for emissions, the Environmental Protection Agency, or the EPA, defines emissions as gases and particles which are put into the air or emitted from various sources. From chemistry class, you've hopefully learned that gas is a state of matter with no fixed shape and no fixed volume. For the remainder of this webinar, please keep in mind that when we're talking about emissions and odors, we're focusing on gases. So a very important part with gases is that they don't like to be in areas of high concentration. So if you're at an industrial site that is producing gases nonstop, you're producing high concentrations. These high concentrations for the gases are not what they want, therefore they want to move to areas of low concentrations, which unfortunately is usually your neighbor. Another point with emissions is that they're highly regulated. They're regulated not only at the federal level by, like, for instance, the EPA, but also at the state and local level. For the EPA, they're constantly looking at how many tons per year of a substance are you putting out. They classify major sources of emissions as sources that put out over 100 tons per year of an air pollutant. And for them, air pollutants are either criteria pollutants or hazardous air pollutants. And then again, depending on what substance or substances that are actually being emitted will determine what type of air permit you actually have to have. It's not as simple as saying, I work at this location, so this is what I have, or I have this type of industry, so this is the air permit I have to have. It's very selective on what you're actually putting out. In addition, there's also the state that comes into play. So I'm going to focus on hydrogen sulfide for a large chunk of this conversation today. And the reason for that is everybody recognizes hydrogen sulfide. It's kind of an industrial standard. It has that lovely rotten egg odor, so it's a good one to work with. So in one state, hydrogen sulfide is allowed at 0.08 ppm, which is 80 parts per billion, for 30 minutes in residential areas. In another state, it is at, it's only allowed at 2 tons per year. So what does that mean for employees and your neighbors and safety? On this slide, you can see that there's a ton of information on here from OSHA about hydrogen sulfide and emissions. So for hydrogen sulfide, it has that rotten egg smell, and many industries make it. And you might not think, oh, my industry might not make it, but it probably does. There's a lot of them out there that do, from wastewater treatment plants to asphalt facilities. And unfortunately, hydrogen sulfide is deadly at high concentrations. And even at low concentrations, it can cause health issues. It's a fun gas in that at higher concentrations, you lose your sense of smell. So you don't even know it's there, and it can hurt you, unfortunately. So what does that mean for industrial sites? It means they have to keep their eyes on it. It means that they have to know what the regulations are, what they are and can and can't do. So remember back a minute ago when I said that in one state, the regulation was 0.08 ppm of hydrogen sulfide for 30 minutes at a residential site. Let's say you're a wastewater treatment plant and you're emitting 0.07 ppm of hydrogen sulfide. You're under that emissions level, so you think, oh, I'm good to go. However, you have residents all around you. And as you can see from OSHA's ranges on there for odor threshold, meaning when you could potentially interact or smell this odor, it's as low as 0.01 ppm. That unfortunately means that while you might think you have your emissions under control, your odor is not under control. So what happens if your emissions are under control but your odor is not under control? Well, it's simply like Brian said before. Unfortunately, that means complaints are going to come in. So let's talk about odor. So let's understand odor. So there's some important definitions I want to just talk about briefly in order to understand odor, especially as we continue on in this conversation. So first of all, odor tend to be thought of as an unpleasant smell. You don't usually talk about, especially with industrial odors, as them being pleasant. There are pleasant odors, of course. I personally like to smell carnations. They smell delightful. But in industry, that's not what you get. You get the unpleasant odors. And and I was looking at this, what those odors are and that they're pleasant versus unpleasant, then you have to look at, well, how much do I actually have and why does it matter? So let's talk about two other terminology things. We have odor detection threshold and odor recognition threshold. So the detection threshold is where there's a minimum concentration where the odor is detected by 50% of the population. That doesn't mean they know what it is, it just means they detect an odor, and an unpleasant odor at that. Odor recognition threshold is where you have the minimum concentration and a characteristic odor can be seen for at least 50% of a population. So let's talk about hydrogen sulfide. The odors detected here is, as I mentioned before, rotten eggs. So let's say at a small concentration, you might know there's an odor there, but you don't recognize it. As the concentration goes up, you do. If you look at the table that I have on there as well for measuring odors and looking at them, you can see that there is a big difference between the concentration for an odor that is recognized versus detected. So that's something key to keep in mind. Just because your neighbors know it's there doesn't mean they necessarily know what it is. It's just there. Another thing to talk about is odor units. So later on in this presentation, I'm going to talk briefly about how to measure odors, what technologies are out there right now. So odor units is key. Odor units is the number of times that an air should be treated with odorless air to reach an odor threshold. So this value gives you an idea of how strong the odors are. And as a note, unfortunately, perception is key. So I like the saying where if perception is, if it smells bad, it must be unsafe. That's not true. As we went over a minute ago, it's all about the concentration. So you can have chemicals that smell at low concentrations and have no issues at all safety-wise. However, that's not the perception of the public. So where does that take us to? That takes us to understanding the difference between emission control and odor control. There's a big difference between the two. And it's really important as we continue on in this presentation that you understand that there is a difference between emissions and odors. Emissions controls can get a lot of the substances that are there. They'll lower these substances down, you'll get in your air permits, but that doesn't mean that the odor is actually under control. There's still substances there that smell. The key is you have to get the substances under the odor threshold. That's what odor control does. It takes the odors and gets them down there. It doesn't mask them, at least the technologies we're going to talk about later on, but it can. There are some that do mask. And for us, as I focus later on, we're going to be talking about plant-based technologies, which are safe and effective and reduce your neighbor's complaints. So while keeping all of this in mind, I'm going to have Brian discuss with you now what types of odor control technologies are out there right now.
Brian, we suspect you're on mute.
Whoa, excuse me, I sure am. Thank you, Dr. Laura. Apologize, everyone. So I'm going to speak briefly about the different types of odor control technologies that are available on the market today. I'll try and tell you a little bit about most of them, and then I will turn it back over to Dr. Laura, where she can be more specific about OMI's area of expertise, and that's the chemistry of plant-based odor control technology. So we'll start with chemical scrubbers. And I will note that most of these technologies that I'll go through do require what you might call a vacuum system. The first thing you have to do is collect the gases and bring them to your odor control technology. Chemical scrubbers are a vessel that will wash the air of odorous molecules. You collect the air, you push it through the scrubber, and then basically scrubs that air. They can be effective at eliminating the specific emissions that they're designed for. For instance, we use acid scrubbers for base gases, and we use base or caustic scrubbers for acid gases. The issues with them can be the capital costs involved. Obviously, you have to build a vacuum system and then a scrubber. You are dealing with hazardous chemicals, and they do have issues with multiple gases. You can't treat both an acid gas and a base gas in the same chemical scrubber because the chemicals required to do that will neutralize each other and they won't have any effectiveness. The next technology I'll move into is a biofiltration. Again, we vacuum up all the air, we collect it, and now this time we push it through a filtration system that's made up of a biomass. That biomass is active with multiple types, strains of bacteria, which will basically then thrive on those odor gases that are sent to it. The areas of issue there are the capital costs. You have to maybe buy land or a large vessel, the space required for the filter media, and then the difficulty, again, in removing multiple gases from a singular airstream. I'll move from there into thermal oxidation. Thermal oxidation is a very well-recognized method of odor control. We collect the gases and we basically burn them. Use heat to destroy the odorous molecules. It is effective on many gases. Has a very high capital cost on the front side. There's also a lot of fuel costs to run the thermal oxidizers. And there are some issues sometimes with the speed of the airflow. Pushes those odor molecules through there too quickly, and you don't get all the odor control that you need. One of the most common methods that most people are somewhat familiar with is carbon filtration. Heck, we even use it in our homes. Most of our refrigerators have carbon filters for the water. You use a carbon media to filter an airstream. Again, we have to collect the gas first and then push it through that carbon. Carbon is a very effective filter medium. The issues are the capital cost, putting in that vacuum system and putting in those vessels to hold the carbon, the space required for those vessels. And then the additional issue with the carbon is once it becomes spent or used up, it can become hazardous waste. It definitely has to be disposed of. And then again, you have your carbon consumption costs. I briefly mentioned masking agents. It's basically taking typical household grape or orange smelling deodorant and trying to produce it on a large scale. That technology is pretty much outdated. It's not very effective. It's certainly low cost, but it's certainly also unacceptable to most regulatory bodies that manage and receive neighborhood odor complaints. And now we'll move into OMI's specific chemistry, and that's the plant-based odor control chemistry and technology that Dr. Laura will go into more specifically. Thank you.
Thank you, Brian. All right, as Brian mentioned, now I'm going to talk about plant-based odor control technology. And in specific, I'm going to talk about EcoSorb chemistry. While there are other technologies out there that use plant oils, EcoSorb's formulations are different. We're different for a number of reasons, but one of the key reasons is that we don't simply use one plant oil in any of our formulations. While you might find out there, especially as Brian mentioned before, with masking agents where you have like a cherry or an orange scent, that's typically what they are. Maybe a few other things in there with it, but that's what they encompass. Our products are different. Our EcoSorb blends are not one or two plant oils, but many different plant oils. The point of the plant oils is to be able to actually react with the chemicals. So let's first understand what this technology is. So we have both odor, or for both of our technologies, we have water-based and oil-based additives. So our water-based products and our oil-based use plant oils. You might know these as essential oils. They're typically found in a lot of consumer products out in the world, so I'm sure you've come in contact with them at some point. So EcoSorb's plant oils come from plants all over the world. They're steam distilled, which basically means you use natural water to pull the oils from the plant. This is the best way to get the plant oils pure, and it doesn't change the plant oils like what happens when you solvent extract them. In addition, for our water-based products, we also use purified water, which might not sound important, but it really comes into play when things are stored outside and in industrial sites. You don't want mold and bacteria in there. So we use reverse osmosis water. It goes through a lot of filtration, it goes through UV lights, and it's very pure water. As you may be aware, and I hope you're aware, oil and water don't mix. So you have to have a surfactant-based product. If you're unfamiliar with the term of surfactant, just think about dish soap. So dishes have oil on them, that's their dirt. And you can't clean them with just water because they don't mix. So you have to use a soap or a surfactant. It's the same idea here. You can't just have essential oils or plant oils and water because they don't mix. So we use bio-based surfactants, and the bio-based surfactants we currently use are found in common foods like ice cream. Our surfactants are non-ionic in nature. That is one of the safest surfactant types you can have out there. Our surfactants are not like the cationic ones like quaternary amines, which when sprayed in the air can cause breathing difficulties. This is essential so that you know when you're using our products, your employees are safe. It's not just making your site smell better, it's also keeping your employees safe and also your neighbors safe. For our oil-based products, the only difference is there's no water. You use a plant-based diluent with the plant oils. And this can go right into any area where you normally can't have water. So for instance, if you're in an asphalt, you can't put water into asphalt, or plastic or rubber industries. All of these can use it. So now the question is, How does our chemistry work? How does this technology work? Well, the first thing you have to do is make contact with the odors. This might not seem like a big deal, but it's a huge deal in order to get this done. So just think about if you're at your house and let's say you have pets. If your pet has an accident in your living room and you spray something to make it smell better in your kitchen, you're never going to make contact. The same idea comes into play with EcoSorb chemistry. You have to make contact. It's one of the keys and why we take into consideration every possible source of where the odors have come from. That way we know you're going to make this contact. So the first step is you make contact through these very weak van der Waals interactions. They're the weakest bond in chemistry. And that happens through a technique called adsorption, where you're just binding that odor molecule to the droplet, our EcoSorb droplet in this case. This is exactly the same type of how masking agents work at this point. So masking agents are very similar. You spray a masking agent in the air, and then you add a droplet to it, or add an odor molecule to it. They have this very weak bond, and then it goes up in your nose, and it breaks apart, and now you have stink with it, which is not what you want at all, obviously. That's why they're masking agents. They don't go further. But EcoSorb's chemistry is different, and we do go further. After adsorption, we absorb. The odor molecules get absorbed into the EcoSorb droplet, and they're held on to. They don't get back out, and the odor at that point is completely under control. This is, however, highly affected by solubility. So the solubility comes into play with the plant oils. You have to use the right plant oils to get the odors under control. This is why EcoSorb currently has over 200 different formulations with different plant oils in there so that we can go after any odors that are out there and get them under control. Once the odor molecule is absorbed into the EcoSorb droplet, chemical reactions can take place. In particular, acid-base reactions take place and result in an organic salt in water. Finally, the droplets will fall to the ground and biodegrade. That is the easiest way to explain how our chemistry works. And with that, I'm going to hand it back to Brian so he can teach you how we distribute the plant oil technologies at industrial sites.
Thank you, Dr. Laura. So as we talk about our distribution systems, the real key with our water-based technology in chemistry treats airborne odors, basically. So we have to have distribution of the EcoSorb products, take the EcoSorb product to the odorous molecules so that they can now be treated. It is certainly possible to create a vacuum system as some of the other methodology. But one of the beauties of the EcoSorb system is you don't necessarily need a vacuum system. You can take the EcoSorb to the odor. Our main form of engineering technology for distribution is our vapor distribution systems. We actually take the liquid, we vaporize it, maybe not by definition a true vapor, but we turn it into a micron-sized droplet that we can then push through ducting and put into the atmosphere at such a small size that it will almost float. And we can take that ducting now and surround any odorous area or actually treat into an exhaust stream from maybe an existing scrubber situation. All our systems have PLC controls. With a vapor system, you don't need any water. Typically, most people understand that you dilute these systems. You don't need to do that in our vaporization systems. There's very minimal maintenance. We offer service programs where we actually service all the systems. We have every type of automation there is, wind, gas sensors, etc. And it's very low capital cost, especially when you eliminate those vacuum systems. I've got some pictures here of some of our vapor distribution systems. You have one on the left. We're actually going into an exhaust stack. Not the blue tall tower, but the kind of tan one next to it is the exhaust stream coming off asphalt fuel tanks and asphalt treatment, where they're actually making polymer modified asphalt. Anybody who has experience in the asphalt industry knows that has tremendously high sulfur contents and that gas coming off there. So our vapor goes into that exhaust stack and then treats it. We put a nozzle on the inside so that we make sure we get to distribution and contact inside that stack. Move to the right, you'll see a Venturi exhaust, and we've got the EcoSorb ducting there. It's yellow. We've got vapor ports that actually feed into where the Venturi exhaust pulls in the outside air, so we make sure we get contact with all the gases. We move to the right, we have an exhaust vent on a building, very similar to what Jennifer will be talking about later today on their tipping floor. That exhaust vent now is turning the air inside that building that's very odorous, pushing it outside where it's just going to carry to the neighbors. So we treat it as it leaves the building. That ring is full of vaporization ports, so we're putting that gas, like this picture here on the right, on this slide here, that's a smoke bomb in that ducting. You won't ever see it when it's actually coming out on site, but we're putting a curtain across that vent so that none of the odors reach any of your neighbors. And then the last slide on the right is, I think that's got 1,700 feet of ducting going around the perimeter of a pond. So we can now treat all the air, all the odorous air coming off the pond. That pond has raw sewage, raw grease, trap grease poured into it. It's extremely odorous. And you can actually stand when the wind's blowing at you 10 feet behind that ducting, and you won't have any more smells. How do we prove that? We do some gas analysis and odor testing technologies, which Dr. Laura will speak about now.
Thank you again, Brian. All right, this is my favorite part of this presentation because I get to talk about GCMSs or mass spectrometers. So let's start off with this. So this is a very unique thing that OMI can offer, or EcoSorb can offer to its customers, in that there's not a lot of our competitors out there that could do this. So what we do is we have to know what you have at your industrial site. So we pull gas samples. You can see in this picture, those are gas desorption tubes. You go out on site, you pull gas samples at the various sources, and then you analyze it back in the lab with one of three methods. The key for this is to understand what chemicals are actually coming off at your sources so we know how to treat them best. For instance, what you think might come off at one part location of your site might not be the same at another, depending on the treatment. Think about wastewater treatment plants. Wastewater treatment plants use different chemicals in different stages, and each one of them emits slightly different odors. You might have a higher concentration of ammonia at one spot and a higher concentration of mercaptans or hydrogen sulfide at another. So it's really important for us to understand what you're facing in order to find the right chemistry to work for your site. So when the gas desorption tubes come back to us, we have to analyze them. So one nice thing about gas desorption tubes is they last 3 to 4 weeks instead of days like your typical Tedlar bags where you would pull gas samples. So it gives us a little time to get around it. So what capabilities do we have? We have a gas chromatography mass spectrometer. So this guy identifies all of our volatile and semi-volatiles that are there. It's a very good technique to see what you actually have. It lets me know exactly what's coming out, so me and my team can decide, okay, which blends we need to use, or do we need a new blend, do we need new plant oils? In addition to that, we have gas chromatography flame-induced ionization, which allows you to detect hydrocarbons. So perhaps we just need to know, do you have hydrocarbons there in general? We'll run a sample there. Or we also have gas chromatography flame photometric detector. This allows us to see sulfur compounds. Sometimes sulfur compounds are a little picky in a mass spec, so again, this allows us to look at those, which is very nice. So when all that is said and done, what does that look like? So here you can see we had a wastewater pond and it needed analyzed. So samples were pulled from around here at different spots. This example here is a chromatogram that shows you exactly what we found. And we identified not only the peaks that are there, but we also can see how much of each of them are there, which is nice too. And we've furthered our technologies to be able to tell exactly how many parts per million you have of each odorous chemical there. And that is also a key to this too, is it's not just being able to detect chemicals, it's being able to say, is this chemical odorous or not? Not everything is odorous just because it's there. In addition, this is what the GCFPD looks like. So if we wanted to know, hey, do we have any sulfur compounds in this situation? This is from the same wastewater pond. We were able to say, oh, yes, we have hydrogen sulfide. So that was a great way to identify something that will definitely smell. So you might ask yourself, well, great. So now we know what gases are in there, but what does that really tell us as far as odor goes? So that's a really great question. Because as I mentioned earlier, emissions and odor are not the same thing. And while emissions and odor play hand in hand with each other, you can get all the emissions under control and not the odor. So let's look now at how do you measure odor. So there's a lot of different techniques out there. The best one that I've found right now and that I use is the nasal ranger. So the nasal ranger technology is a field olfactometer. It measures and quantifies the odor strength in ambient air. It does this by creating a series of dilutions by mixing the odorous air with odor-free carbon-filtered air. The dilution level dial on it, you turn it, and the odor is detected. The nasal ranger has a range of 0 to 60 odor units, but you can add an additional dial onto it to get up to 500 odor units, although that is a lot. 600 odor units is pretty much considered run out of the room. So it smells pretty bad. Recently, a lot of local level regulatory groups, so we're talking like your cities and counties, have started to use the nasal ranger over the last 10 to 20 years. And when they use these, they're looking at, well, what is considered a nuisance odor? And to them, the standard is 7 odor units. So if you're below, you're good. If you're above, you could be a nuisance to your neighbor. So you can look at, okay, what do I have at the fence line and what do I have in the neighborhood? And really be able to tell, like, are you an issue or not? So in one of the sites that we went to, we looked at the fence line and our untreated odor units were 8.4 on average. The treated odor units were only 0.8. So that was a huge reduction and well under the 7 odor unit nuisance level at fence line, meaning that the neighbors did not have a nuisance. Keeping all this in mind with how to measure odors, I'm going to now hand it over to Jennifer because she's going to discuss with you a case study that uses both our EcoSorb technology and the nasal ranger.
Good afternoon. Thank you, Dr. Laura. My name is Jennifer Clennert. I'm with FOS Environmental. We're the strategic consultant and engineer for the Ramsey, Washington Recycling and Energy Center. Just a brief introduction to the facility. It's a waste processing facility located in Newport, Minnesota, which is a southeastern suburb of the Twin Cities of St. Paul and Minneapolis. It processes approximately 450,000 tons per year of garbage into 3 separate products, into ferrous, non-ferrous, and refuse-derived fuel for energy production. The facility was built in 1986. Part of the reason that FOS became involved with the facility was that in 2016, Ramsey and Washington counties purchased the Recycling and Energy Center. With the change from private to public ownership, there was increased political pressure from county boards, from city elected officials, and state representatives. And the focus became on being a good neighbor. There's also, as Dr. Laura alluded to, there are odor ordinances in place in the surrounding communities of Newport and South St. Paul. Just kind of a brief update, and I'll show you here next a little bit about the facility. The Recycling and Energy Center is actually located within 1 mile of 4 cities and 3 counties. So it is in a unique location from that perspective. There are approximately 18 odor generators within 1 mile that include a wastewater treatment plant, compost site, rendering plant, pet crematorium, steel manufacturer, and bagel bakery. There's a lot of confusion on the part of residents about what exactly is causing the odors. The facility itself is landlocked by a freeway bridge, the Mississippi River, and an electrical substation. And on top of that, there's a 250-foot increase in topography from the Mississippi River to the top of the bluff, which is less than 1 mile. And this causes unpredictable winds and odor pockets. FOSE has spent the last 5 years studying different aspects of the odor and assisting the Recycling and Energy Center with putting things in place to help mitigate the odors from a waste processing facility. Some of the things that we've done over time include air dispersion modeling. We've done wind roses for prevailing winds and seasonality to find out where the odors are actually going to. There was actually an airflow study that was done by Emmanuelson POTUS looking at the facility fans and air release points. And just a little bit about this facility, it was made to breathe. There's 2 areas in particular, the tipping floor building, which is where the garbage is actually emptied from trucks onto the floor. There's 7 active roof ventilation fans that each push 65,000 cubic feet per minute out. And then there's a processing building that has 6 active roof ventilation fans that each push 42,000 cubic feet per minute, and a dust collection system with 2 fans that push 48,000 cubic feet per minute. When the airflow study was done for the facility fans and the air release points, what we discovered was that approximately 70% of the air emissions and potential odors were coming from the dust collection system, and that 30% was coming from the tipping floor itself. I apologize. This next slide actually talks a little bit about the options for management. So there were 3 options that were chosen back in 2017 to manage the odor. And odor is always a journey, not a destination. Odor management is a journey, not a destination. The first thing that was done at the facility is we looked at how to reduce airflow. There were garage doors that needed to be replaced, and there were fans that needed to be shut off when they were not processing waste. The second thing that was done at the facility is treatment. So I'll show you examples in a moment here, but we did put in 2 vapor phase systems that push an odor neutralizer. We do use OMI systems out over both the tipping floor as well as through the dust collection system. And then there's a lot of monitoring that's going on. So there was a weather station that was installed on top of the facility. It is set to alarm when we have a north-northwest wind that's between 4 miles and 10 miles per hour, because that is the ideal odor conditions for that facility. FOSE does have an odor team that does use the nasal ranger. We go out twice a week during the summer, once a week during the winter, and also do quite a bit of bare nose monitoring as well. This next slide is just an example of the system that we have over the tipping floor. So it's a 60,000 square foot tipping floor where we're dumping garbage. And you'll see PVC piping up on the top right and the bottom left, and that's actually pushing to those 7 active roof ventilation fans. On the left is the OMI system. It is located outside, so there has been a doghouse built around it, both to protect it and also to control the temperature. So that's the first system for the 30% of the odors. And then this is the second system that's over the dust collection. And so the dust collection puts neutralizer directly to the dust collection system. We're also working on enclosing the facility so that long-term there can be less odor released. FOSE and the Recycling and Energy Center did have Dr. Laura come out and use the mass spectrometer to be able to measure the chemical makeup of the MSW. Originally, we used a product called EcoZorb 606, and then upon doing the chemical analysis of what was coming from the heterogeneous garbage, we did switch to 106, and that's part of why I say that it's a journey. You can't ever be happy with the results that you have. I just want to talk a little bit about next steps. We're going to be continuing odor monitoring with the nasal ranger. So that's a long-term plan. Currently, we're revising standard operating procedures. This controls how waste is managed on the floor to make sure that it doesn't sit too long. There's going to be formal staff training next year. If you smell something, say something. Odor management for this facility is second only to safety. So they're very focused on odor management. We will be doubling the size of the vapor phase system that's going through the dust collection system so that it can handle the processing building in addition to the dust collection system. Next year, we'll be reevaluating the airflows of the facility and also expanding community outreach. So with that, I will turn it back over to Brian.
Thank you very much, Jennifer. We appreciate you sharing with our guests this presentation, how my system, our chemistry and expertise and technology actually works for someone in the field. This last slide, before we move on to questions, I just want to share with you all the different markets that we use our plant-based odor control with. There are over 200 EcoSort products. Jennifer brought that up a little bit. We have a dozen or so base blends in the water-based and oil-based additives, and then the rest are many, many different types of custom blends that were created either for a specific industry or a specific situation. So if we're not dealing in your situation already, we certainly can develop an EcoSort that will do that, but we have systems in the asphalt marketplace, metal casting with a foundry business. We do a lot of pet food manufacturing, petrochemicals, wastewater, both municipal and industrial, solid waste. As Jennifer mentioned, we do a lot with soil remediation sites to allow them to keep moving and keep working while they don't have any odor issues when they're using us. Refining petroleum, the pulp and paper markets, and our newest market, oddly enough, is cannabis cultivation, because when you grow cannabis and you push a lot of air through those greenhouses, it creates a tremendous odor in the neighborhood. And we actually developed specific EcoSort product for the cannabis odors and those terpenes and cannabinoids that give off a skunk smell. So we're in a lot of markets. If we're not in there already, if we don't have the expertise that we've done it before, we certainly have the ability to do gas testing analysis, odor testing, and then develop a custom blend for your specific needs. With that, I thank you all for your time, and I'll turn it back over to Kevin.
Well, thanks so much, Brian, for what was, really a very interesting and informative presentation. And thanks for Jennifer and Dr. Laura as well. To our audience, please send us your questions now. We'll get to as many as time allows. Dr. Laura, the first question I'm going to ask from our attendees is one from John, and he asks, we have a regulatory permit restriction with VOC limits to limit emissions below major source threshold. Is your product considered a VOC, and would it need to be accounted for in overall facility emissions?
All right, thank you, Kevin. So yes, when it comes to plant oils, they are volatile organic compounds, or VOCs, for sure. Plant oils are, that's their nature. They're non-hazardous volatile organic compounds, and that is important because when you're looking at it especially from a regulatory point of view, they don't want to see anything that's hazardous like benzene or toluene being added into these situations. So for us, yes, they have to be considered. And when it comes to your overall facility, yes, they have to be taken into consideration. I will say that we have a lot of customers that are in that same situation where they have permits. There's only so much they can have. It has to be accounted for, and we work with them. We help them understand what they're adding and putting out in there so that they can stay within where they have to for that permit.
Thanks, Laura. Brian, the second question is for you. And Robert asks, where can I go to find information on verification and validation, perhaps such as white papers?
Kevin, I'm going to leave that one to Dr. Laura.
Great.
So when it comes to how do we verify in that, we have a couple of ways. So number one, we provide anybody that needs it with our engineering manual that has a ton of third-party testing in there that's already been done. There's also white papers in there on like studies we've done as well. And then as moving forward, we've had some customers that have done third-party testing and studies and given that to us. So yes, we have those resources, and we can reach out to you and provide you with whatever you need.
Well, thanks, Dr. Laura. Another question for you from Bob, and he's asking, does eNose technology effectively measure odor?
Yes. So my answer to that is no. So eNoses are very complicated. They have a lot of sensors in there, and they don't necessarily work the way you hope they do. So nothing can mimic the nose like the nose can. The eNose tries, but it can't do it, unfortunately. So with that in mind, that's why I particularly like the nasal ranger, because you're using your nose to actually smell it. And another issue with the eNose is that those sensors, as they sit out, they can get damaged, which can cause issues. They can have, if they hit with too much of a high concentration of something, it can really throw them out of whack. They have to be recalibrated all the time. So in my opinion, eNoses are not the way to go.
Great. Thank you, Dr. Laura. Brian, I apologize for misdirecting the previous question, but I'm going to try you again here. One of our listeners, Sherry, asks, have you done work in the healthcare industry with odors related to autoclaves?
Thank you, Kevin. Yes, we have. We dealt with, probably the first time we did that was maybe 20 years ago. And so we deal with medical incineration in several applications over the years. And it's something that we'd be happy to talk with you about.
Great. Thank you, Brian. Dr. Laura, another question for you. Is there any consideration for areas with dangerous gases or substances in which the odor may be a condition of alert for a leak or risk condition?
Yeah, so that's definitely something you have to take into place. So in those situations, one way to look at it is, like, for instance, like, let's talk hydrogen sulfide again. That's going to be my favorite gas of the day or the week. So hydrogen sulfide is extremely toxic. So the question comes down to, well, if you put our products out there and, like, will you know if it's there? Can you smell if it's there? So the key to that is, in the case of hydrogen sulfide, is making sure you still have those sensors there in case it doesn't get it at all. So if our technology is working the way we want it to, it's going to reduce what's coming off. You're going to have less odor, and you're going to have less emissions, hopefully, or you will. So in the end, it should make the whole situation safer. It won't make it worse. But yes, you have to keep some kind of sensor there going on. Otherwise, you could potentially put your people in danger.
Thank you. Another question, I think we're getting pretty specific here, but I'll give it a try. Dr. Laura, do you have a solution for ammonia in leachate wastewater with high concentrations up to 3,540 parts per million?
Wow, that was a very specific one. So to answer that question is, yes, we can take care of ammonia odors for sure. We actually have a number of solutions that work with ammonia odors. So what we've found, and I'm sure is probably the case for this situation as well, it's never just ammonia. Yeah, ammonia is the worst one, but it's never just that. And so you have to look at what else is there too, because you can't. It has happened where you get the ammonia and there's still a smell because you didn't know about the other ones. So that's why it's so important for us, at least, to do the gas testing as well. And then we bring our equipment into it too. So with our equipment, we know how much vapor phase systems we need and we have to use, and how much of our product we need in order to really knock that down. So yeah, I would say bring it on.
All right, well, thank you very much for that. Another quick question. Are there any types of compounds that would interfere or obstruct the effectiveness of the EcoSoar?
Yeah, so that's a great question. So the simple answer is no, but but kind of yes. So I'm actually gonna use Jennifer's situation as a great example for this. So at the Ramsey, Washington, we first said, okay, based on like what we've seen in the past, let's use 606. And then we came in and said, let's do gas testing, and we found that actually our EcoSorb 106 worked better and got more of them. So the real issue isn't necessarily that there's a compound that's interfering or obstructing it. It's just we're not getting the right compounds. So it's really important to know what is actually in there so we can determine, okay, what reactions have to take place, and we know which plant oils then to bring in so we can get the right blend to get it done.
Great. Thanks, Dr. Laura. Brian, are there EcoSorb solutions for petroleum, diesel, and or rubber smells?
Absolutely, Kevin. So we deal with rubber quite a bit. We actually developed an additive to go into rubber gym mats so they wouldn't smell when people actually put them in their gyms. We actually took the smell completely out of the mat itself, along with taking the odors out of the neighborhood from the factory where they made them. We deal with petroleum and diesel odors, both in refineries, petrochemical plants, and also in remediation sites. Again, a lot of the remediation sites around the country and around the world where they're doing cleanups come from the petroleum industry, if you will, or petroleum-based products that are causing the issue. So we deal with those on a continuous basis regularly. Great.
Dr. Laura, this idea of the fact that there's no machine or sensor for odors is of interest of me. I just think it's fascinating, and apparently to one of our listeners as well, who asked, is there a simple way to quantify or measure the odors in industry, or is it simply just a matter of the person who is smelling the odors?
Yeah, so for this one, I'm going to stick with my strong opinion on at the moment that the nasal ranger is the best way to go, because it is using a human nose, and it is able to give you a quantified number of what those odor units are. That's what that technology does. So you can stand at your fence line or stand in the neighborhood and really know this is how bad it is at this point. Is it a nuisance? Is it not? I'm going to stick with that's the best way to go.
Good. This is pretty much the final question of the day, and Dr. Laura, since so many went to you, we won't make an exception here. But the question is, how do you recommend improving indoor air quality and odors that are inherent in an HVAC setting?
So I'm gonna let Brian handle this one, and the reason I'm gonna let Brian handle this one is because he has a lot of experience out in the field dealing with these situations, and I think he will give the best answer.
Thank you, Dr. Laura. Yeah, so we've both done that once now. So the HVAC systems are really easy to deal with. I mean, we can vaporize an EcoSorb blend into that HVAC system, and it will then carry throughout the entire area. Wherever that HVAC system is treating, we'll eliminate the odors in it. It'll take care of any intake odors and any exhaust odors where that HVAC system is then putting it out to the room. We've done that in many locations around the world for many, many years.
Good. Thanks, Brian. I said the last question was going to go to Dr. Laura, so to be true to my word, I'm going to ask her the question that Jim asked. How about training dogs? I am told that dogs smell well. Okay, is there a role for canines in this industry?
You know, like canine dogs they do have a great nose, and dogs, they smell a lot better than humans do. But now think about that. If you're at an industrial site and it's terrible, can you imagine how much it would be for the poor puppy? Yeah, I can't imagine. So to me, I think for the safety side of things, no, I would not put a dog in there.
All right. Well, thanks for going along with us there. That's about all the time we have questions for today. And I just want to thank our great speakers, Dr. Laura Halpert, Jennifer Clennert, and Brian McLaughlin for sharing their time and expertise. I'd also like to expend special thanks to EcoZorb for sponsoring today's event. Now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcast. Finally, on behalf of Plant Engineering and EcoZorb, I'd like to thank you for attending. This concludes our webcast. Thank you and see you next time.